All right, so first of all, we have three problems in one. We have when it's greater than, equal to, and less than. In fact, you know what? I'm going to do this. That one doesn't matter. I think that'll be better. All right? So we have this one thing, x squared minus 4x plus 3. That's one thing. It could be 0, it could be positive, it could be negative. Can it be anything else? Or does that cover all three possibilities? Yeah? So, let's solve this one that we're used to. So we factor it. And set each of these equal to 0 and solve. Let me do that down here. So at 1 and at 3, I can make a 0. Can I make 0 anywhere else? No, right? So all the other points aren't making 0. Is that clear? Which means all the other points are either going to make a positive answer or a negative answer. Right? And so all we have to do is pick a number from this region. Pick a number. -2. Good choice. Pick a number from this region. And pick a number from the last region to the right. 4, good choice. Okay, how about 42? That's even better. Now, I could plug it into the original, but I'm lazy. Let's just plug it in here. If I plug in -2 here, it's negative I don't care. If I plug in a -2 here, it's negative I don't care. Because what's a negative times a negative? That's all I care about. That region, guaranteed, will produce a negative for both factors and will then guaranteed produce a positive for that whole polynomial. Does that make sense? If I plug in 2, this is still negative, but now this one's positive, isn't it? I'll bet you every number between 1 and 3 has that same fingerprint, negative and positive. What's a negative times a positive? Negative. And then if I plug in 42, clearly they're both positive. Meaning, if I plug in any number, right, to the right of 3, any number, they'll both be positive. Is that right? And so then, hey, I think this one are these two. So, negative infinity to 1. Do I include 1? No, I want it to be positive, not 0. Union, where else is it going to be positive? 3 onto infinity. You fill out the answer for the last one here. And I hope you know that it's between who? 1 and 3. Do I include 1? No. Do I include 3? No. All right? So if I were to give you a list of instructions, step 1, set inequality, because these are going to be less than or greater than. So actually the questions are going to look like this or like this. Right? That's what we're studying. Set the equality to 0. Notice I didn't say equal to 0. It's not an equal sign, is it? It's an inequality. we set it to 0. So if there are things on both sides, make one side 0. Step 2, we solve the equality, like the middle guy. And I'll do that either by factoring, quadratic formula, whatever the case might be. Okay? And if I solve the equality, I'll find the critical values. Or the boundary conditions. Make sense? Boundaries? And then, once I have the regions, because I have the boundaries, I just have to test the regions. Like we did here, we picked a number to represent each region, right? And we came up with the signs. Again, don't be too much into details. You don't care about what these actually become. You just care about what sign they become. How are we doing? I'm going to try that for the next example. So, since it can be or equal to 0, 0 actually works. Now, to be honest with you, I'm not sure how to show that. Maybe we can do this. Or some people go, how about if I have like 0 to 0 be an interval? I go, I guess so. It doesn't make much sense to me, but does it not make sense either? So I'll take either way. But very good. Yeah, 0 does work because it can be 0 as well as negative. I just ignored the or equal to. And so, but the or equal to does allow me to include the 6 and the 8, doesn't it? That's why those are brackets. Very good. Let's change this slightly. Let's say that this package had another name. Its name is y. Okay? Function now that depends on x. So when it's positive, y is up. Y is still up. Now it's down because it's negative, and now it's up. You see that? So that positive means above the x-axis, negative below the x-axis, and 0 on the x-axis. You know that. You just probably didn't see that coming. Same thing here. Positive above the x-axis, negative below, positive above. And so the question always comes up, do they always alternate? And this next example shows you why it doesn't always alternate, right? Alrighty, how would you do this one? All right, so first off, you hope, you wish you could factor it. If the signs were different, we could, but we can't. And so we have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And what's the issue? We have a negative number under the radical. The discriminant is negative. It doesn't cross the x-axis. So we don't have any critical values, which means we have one region with no boundaries, from negative infinity to infinity. So let's continue the process. Let's test the region. I love plugging in 0, don't you? And what do you get? 5. 5 is positive, meaning the whole region is positive, meaning this shape is always above the x-axis. And for now, whether it's that or this, I mean, you probably do know it's this and it's not this, but basically it's something like that, right? So this is what? When does that happen? When is it positive? When is it above the x-axis? Always. From negative infinity to infinity. When is it below the x-axis? When is it negative? Never. Meaning, I haven't changed anything through all the examples. But they look different, don't they? But you have to interpret them with what everything means. Not what's step 1, what's step 2, what do I do, what do I do? All right?